Hello class, and welcome to our last video for our Business 308 Statistical Analysis class. This is Dr. Mo. I'm gonna take you today and just finalize our analysis for the problem we've been looking at in the lectures about salaries and gender. So today we're looking at week 4. You want to always make sure to read what it says here to earn full credit for each question. You really need to show your formulas, you need to answer each question, so go over each line in your Excel file and make sure you answer the question in as much detail as possible. And also you always want to tell me where's the data that you used. So let's start with the first question. The first question is asking us what is the correlation between and among the interval and ratio level variables with salary. So here we're only interested in the correlation of salary with not all the variables, so we're not interested in the nominal variables like gender or degree. We're only interested in the interval ratio level variables. So let's copy our data, put it somewhere here, start working with it. So we will need salary. Salary. Let's put that somewhere here. We're gonna need now all the interval and ratio level data, so we're gonna use midpoint, age, performance rating, service. We're gonna need all these. We're also going to need, let's see if there's anything else, raise. We're going to need that as well. That's also an ratio level data, as you can see. And we're going to put that here. Okay, so first step is to copy the data. And now we need to create a correlation table. So we're just going to highlight our data. And then go to our data analysis toolpack and select correlation. Okay, so let's highlight our data. So here's our data, and yes, there is a label in the first row, so we leave that checked and press OK. So here is our correlation matrix. You can copy that. They're asking for it in cell K8. So here is K8. Paste that here. So this is of course a symmetric matrix, so they're only giving you the lower half of it. So you can read here that of course correlation of salary with salary is 100%. Correlation of salary and midpoint is 0.98. Salary and age 54, so kind of weak. Salary and performance very weak, only 0.13. Service 0.45, and raise almost no correlation. So I want to make this column yellow because this is what we're interested in, salary. Now, one thing you need to remember is these values right here are sample correlations. So we need to set up a hypothesis test to see whether or not this correlation is significantly different from 0, because maybe our sample is too small to generalize the finding, or maybe we just picked random samples that happen to give a strong correlation, but if we pick another random sample we don't get that strong of a correlation. So we really have to test this correlation. So normally we would do a hypothesis test, but in this assignment we're gonna make it easier for you. So we're just gonna essentially compare our sample correlation we got here to a critical value. If we have a sample correlation higher than that critical value, we will conclude that it is statistically significant. If we get a sample correlation less than the critical value, then we will conclude that it's not statistically significant. So what's the t-value we're going to use? Well, we're assuming that we're testing at alpha 0.05, so the t-value, again, we can get that from the inverse, the t-inverse function. So t dot n Now this is two-tailed because correlation could be positive or negative. So dot two-tail, and then just put a parentheses and press here to open the window. So they're asking you, okay, what's your alpha? So our alpha is 0.05. How many degrees of freedoms? Well, we have 50 data points, so degrees of freedoms will be n minus 2, so that's 48. So we get the t value right there, and now using this t value and the formula in the lectures, we can find the critical value of the correlation, which will work as our line in the sand. So if our sample correlation is higher than that, we'll consider it significant. If it's lower, then it's insignificant. So the formula is square root of the t value square, t critical square over t critical square plus any degree of freedom. So equal square root of this guy squared plus divided by parentheses this guy squared plus degrees of freedoms, which is 48 in our case, and then we close all the parentheses, we get 0.2787. So now you can see by comparing salary, we have salary and midpoint, this is significant, salary and age, significant, salary and performance, not significant, not high enough, salary and service is significant, salary and raise, not significant. Okay, so you're going to summarize all of this in here. So what variables are significant, and then comment on this, any surprises, which one did you expect to be significant, which one you didn't expect, and why. So make sure you answer questions D and E based on your observations. Okay, the next step in the analysis now is to try to develop a regression model or a prediction model to predict the salary using not only these variables, but in addition we want to use also gender and education. Okay, and the reason why is we want to see whether or not gender is a factor in predicting the salary. Does it play a role in that? So that will help us answer our final question for the project there. Okay, so first question is ask you to add the dummy variable values to the right. So let's add them. So our variables here are, we want to add gender. So we want to add that as an independent variable, and we want to add degree just to see if education is also a good predictor for salary in this company. So this is our dependent variable, and this is our list of independent variable or predictors. Okay, so again you're gonna tell me where your data is, and then let's run the regression and see what we get. So we're gonna go data analysis, regression. So our y, which is our dependent variable, is salary, and then we have a bunch of x's, which are these guys right here. These are the predictors, and yes, we do have labels on the first row, and leave everything else unchanged. Okay, so here's our output. So we're gonna go ahead and copy that. To here, they want you to put that M34 right here. Okay, so here's our output. I deleted some salaries, but that's not important. We already did the analysis. Okay, so let's look at the questions now. The first question we need to ask is to test the significance of the model. Is this model in general significant? Do these variables combined help in predicting salary, or is the model insignificant? So the null hypothesis here is that the model is regression equation is insignificant, and the alternative is that actually it is significant, and we're going to test it at the 0.05. Now to test this hypothesis, we're going to rely on the ANOVA part of the output right here, and this is your p-value right there. Just some of you made this mistake. Anytime you see E and then a number next to it in Excel, this means times 10 to the to that exponent, so that's called exponential notation. So this number right here is very, very small. This is 2.41 times 10 to the negative 36, 10 to the negative 36. So that's 36 0 before the 2.41. So that's technically a 0. So the decision rule here is going to be, of course, if p is less than alpha, which is 0.05, we're going to conduct the test. And in this case, you can see that we can reject the null, that the model is insignificant, and conclude that the model is actually significant. So that's your first step, is to make sure that the model is significant. Now that we know that the model overall is significant, we have to see which variables are actually significant. Maybe some variables are useless and are not doing any job in predicting the salary, and essentially we need to remove them from our prediction equation because they're not really related to salary and don't help predict it. So in that case, we want to look at each variable independently, and we want to look at